What is the acceleration vector for projectile motion? Oh boy, that sounds complicated. There must be some complicated formula for that, right? Because we're talking about, like, one example of projectile motion might be like a projectile that is launched over level ground. So again, we've drawn a picture sort of like this before. I do it better sometimes than other times. And if I kind of said, like, well, what's the acceleration like right here versus like some point over here versus maybe right at the top there? Well, here's the thing. The acceleration is always the same. The object, even in projectile motion, is always falling down. That's kind of what we talked about, I think, when we looked at motion in 2 dimensions. We said that projectile motion is inertial in the horizontal direction. In the vertical direction, it is just free fall. So in other words, wherever you are, the acceleration vector will be a vector. So whether I'm here or here, and maybe I'll just label these with a vector just to be clear, I'm talking about accelerations. The acceleration always is straight down. The only reason why the projectile moves differently than something that was thrown into free fall or let go into free fall in some way is the fact that it has inertia and it had some initial horizontal component of motion that it maintains throughout this projectile motion, but it is always falling straight down. So that means that the answer to this question in terms of components is the same as it was for free fall. The x component is equal to 0, and the y component is simply equal to minus g, where g represents the free fall acceleration of 9.81 meters per second squared. So let's go ahead and check that answer, and lo and behold, it is. It's the same as for free fall. Amazing, huh?